Okay, so we have different evidence from neurology that has been very useful in informing us about the neuroscience of attention. Mostly this evidence comes from patients with neurological impairments or neuropathology in the right hemisphere. So one curious thing about attention, at least as we conceive it, is that it's often associated with brain impairment in the right hemisphere and not with the left. And that's true across cultures, interestingly. So it doesn't matter if it's a person from the West or a person from the East. The same phenomenon occurs. We know that because we studied this in Hong Kong with a type of cognitive testing battery called the Oxford Cognitive Screen, the OX. And we found that it doesn't matter what your first language or your ethnicity is. We always get this pattern of the right hemisphere showing more difficulty with attention than the left. So, from what we know in the neurological clinic to studying attention in the brain is quite a leap, and we're nowhere near complete in our explanation of attention in the brain. So I'm a little cautious in making any strong inferences here, but since the textbook does, then maybe I'll have a go. What we do know is that, let's start with something that's very well known, the frontal eye fields. So in this case, we've come across the frontal eye fields before. These are the areas of the frontal lobe that are necessary for controlling eye movements. And this is really a key to understanding attention, because in order for us to focus our attention on a particular object in time, we have to use saccadic movements of the eyes, and they have to be done in very fast time, around 170 milliseconds, and we have to be able to engage our frontal eye field cortical area to be able to track objects in the visual world. Without that ability to track via the frontal eye fields, then we'd end up dead meat in the jungle eaten by a lion. So this is a basic skill that we need to survive. So frontal eye fields, we know these are the areas that are important for visual, sustained attention. Notice I'm using the word visual. Visual attention, which is sustained. Sustained, we discussed previously. Visual, because it's the eye movements. It's nothing to do with the ear or other sensory input. Of course, sustained attention for auditory input is obviously present. We can track with our ears the presence of objects in the environment through sustained attention. So we can focus on the sound of a bus coming. So let's say we're running to catch a bus. We can hear it in the distance. We can judge whether we're going to make it or not by running to the bus. If it sounds like it's really close, then maybe we won't bother running because we know we're going to miss it. If it sounds like it's, fairly far off in the distance, then yeah, we'll run and maybe we'll get the bus. So attentional system in the auditory domain also is helpful for our adaptation. The auditory system is less well studied, I must say. The visual system is very well studied in cognitive neuroscience. The auditory system, I would make a guess, is likely to be somewhere in the temporal lobe, but we don't yet have a good, clear location in the temporal lobe for sustained auditory attention. Let's look again, though, at the posterior parietal lobe. So recall that this is the area where damage leads to visual neglect, simultagnosia, and other disorders that we see in the clinic. And with right hemisphere damage, of course, the left side of space, the left visual field, would become impaired or ignored. Now, the posterior parietal lobe we think is necessary for not just the ability to engage with objects in the visual field, but also to disengage. So, engagement of attention is what we think the posterior parietal lobe is doing at a minimum. There's probably many other things that are going on in the posterior parietal lobe for attention. but disengagement is one of those things. If we move now to the subcortical regions like the pulvinar and the superior colliculus. Now, this is the thalamus, so remember that the thalamus is the relay station. Here's the brainstem, and the pulvinar and the superior colliculus are a part of this region that meets the thalamus. We think that from studies of animals, not humans actually, studies of animals that are given artificial lesions in the pulvinar or the superior colliculus, that the ability to alternate attention is the function of the pulvinar. So to switch from one object to another in an animal, like a rat, will become impaired if the pulvinar is damaged. So to alternate attention is damaged. And the same with the superior colliculus, particularly in the case of visual stimuli. But this raises a question that is still very much in its infancy in research. And that is attention a unitary phenomenon? So is attention some kind of resource, like a bottle of water, and we can put some of the bottled water into one cup or another, and the cup that is vision receives so much water, the cup that's attention is getting a little bit more water? Or is it the case that it's not necessary to assume the bottle at all? We don't actually need a bottle of water. We can just assume that each of the systems that are sensory, like vision or an audition, they have their own allocation of attention. So they've already got their resource of attention allocated, and they can deploy that attention in any way they wish. They don't have to top up vision, and vision doesn't have to top up audition. They're independent or modular of each other. This is an age-old question. Interesting thing about modularity and the question regarding attention, because in the case of cross-modal attention, we see quite interesting phenomena. If we are given a task of listening to a face producing a phoneme, then if we focus our attention on the lips of the face moving, which we tend to do in normal speech perception, then we can be fooled into thinking that the sound we're hearing is the same as the sound that the lips are producing. So the lips might move to produce ba, pa, da, but actually the sound that is being presented at the same time as watching the lips is just pa, pa, pa. And people believe that they're actually seeing or hearing ba and da as well as pa. We call this the McGurk effect. And the McGurk effect is actually a tendency to misperceive information that's flowing through the auditory attention channel as a consequence of focusing on the visual attentional channel. And that means that at some level, attention is cross-modal. It means that it does spread from one to the other. So the idea of a unitary attentional resource, our bottle of Perrier here, is still a viable one, and we're a long way from understanding completely the process that allows these cross-modal attentional effects to occur. And finally, when we look at the frontal lobe, in the anterior portion, which we have come across before, the anterior cingulate gyrus, remember we learned that this is very often self-referential. And the prefrontal cortex, which we know from Phineas Gage, if damaged, will lead to disinhibited behavior, that is, behavior which is not appropriate, perhaps vulgar behavior, swearing, etc. This is the kind of thing that we see when the prefrontal cortex is damaged. But in addition to this, we believe that the type of attention that is most likely processed within the prefrontal and anterior cingulate cortex is divided attention, which is to focus on one topic or one task and to inhibit the other. Now, in the case of Phineas Gage, you remember that was true, that he was unable to inhibit behavior that was not appropriate to the standard, the social standard of the time. And so this idea of disinhibition being part of the activity of the prefrontal cortex maps onto this notion of a divided attention system. But having said all that, we're still a long way from understanding fully the cognitive neuroscience of attention.